Good day. Here we are again doing another lab in pneumatics. We're doing lab 5, pneumatic valves and cylinder inspection. This will be part 1. We'll just look at valves, and then part 2 we'll look at cylinders. We will disassemble and reassemble several types of valves, and by the time we're done we hope you'll be able to identify, describe and sketch different types of valves, understanding the construction and how they work. I've started to disassemble this poppet valve just so you don't have to watch me doing and undoing screws all the time. The poppet valve has 3 ports, port 1, port 2, port 3. Port 1 is usually where we would put the supply pressure. Port 2 would go to our cylinder or wherever else we were using the air, and port 3 would be an exhaust port. Normally the spring underneath is pushing the poppet up to its seating position, and you should be able to see in here the seal and the seat that it goes on. When I apply pilot pressure to the top of this valve, it moves down. You can see it doesn't move very far, but it doesn't have to move far for the air to open. When we get this apart, you'll see that there's a large area that the air can flow through. At the same time, when I open up port 1, I close port 2, and you can see, hopefully see it moving back and forth again. Not very much, but I can feel it moving, so I know it's moving. It opens and closes to connect with port 2. Port 2 will always be connected to either port 1 or port 3, and in fact when you're switching from one position to the other, it's connected. They're all connected. Screw here, take pieces out, fall all over the place. This is the elastomer seat or seal, and in here is the seating surface that it presses against. So this is in here, and it fits in just very carefully. It will sit in there, move up and down, not very much. In fact, not even that much when it's in place, but that allows, if we see, we have port 3 is here, port 2 is here, and port 1 is way down in the bottom. So we see at the top we have a seating surface here between port 3 and port 2. I'm going to flip it over, and we'll see on the bottom there's a seating surface here between port 1 and port 2. So we can, always one of these will be sealed off. We're going to put it back together now. I'll take my bottom seat, slide it in there. Take my top one, drop it down, put the diaphragm on. The diaphragm is because this is pilot operated. You can also have these solenoid operated. This gets on there. That's that part together. That'll go on there, and pressing on the spring holds the valve in its normal position. The top here, it allows it to act on the top of the diaphragm back here to push that down. And I just will finish closing this up. Line everything up here and drop this back on the way it should be. I'm not going to tighten it up because we'll be taking it apart again sometime soon. So this is a 3-2 poppet valve. It's a very large body valve for what it is, but that's the way it goes with a poppet valve. We also, I'm going to show you a 2-2 poppet valve. This one is solenoid operated. We can see from underneath pressure on this side. It goes out that way. There's no exhaust port on this one. It's solenoid operated again, so the pressure will open. There's a small diaphragm in there that will compress against the spring or not to allow air to pass through. I'm not going to take this apart because it's small pieces. This is a rotary disc or rotary slide valve. It has 3 threaded ports, 1 inlet, 2 outlets, and it has an exhaust port which will leak out through here. There's the port actually right in there to exhaust the air. This valve you cannot connect it any other way than the way it says, in and 2 outlets and the exhaust. And now we'll take it apart and see what's inside. There's a lot of pieces in this one, and I expect to see them flying all over the place. As I said, flying all over the place. So here we see in the body, you can see where the inlet comes here, I hope, and another outlet to that hole, and this outlet to this one. So we have in here, we've got springs in each of these to hold the element against the sliding disc. These just sit in here. This is lots of fun. They're interchangeable, which is a good thing. Ha. It'd be nice if they'd stay in place. Okay, so the meat of this is the slide. The rotary disc, it slides around however much, that's about 90 degrees. There are 3 holes here to correspond to those 3 holes, but we'll find that the hole here connects to my exhaust. Put the wire in, we can see that it goes right through nicely like that. So that's connected directly to the exhaust. These 2 holes are connected internally. It's been plugged here from where they drilled through when they manufactured and then sealed that up so it doesn't leak. But if I have any luck with this, apparently not. I find that I need a better wire to do this with. No, I can't get that through. They are connected through there. We have managed to stick a piece of wire through to see, but not visible in the camera. So when this is on these down here, we have the inlet is on this side. So I can either have the inlet, as this rotates, the inlet will connect to this one, or if I rotate it the other way, the inlet will connect to that one through these 2 holes. It's either this way, let's put it this way up, it's either this way so that the inlet goes to this port, or it's this way so the inlet connects to this port. The port that isn't connected to the inlet will be connected to the exhaust, because it would just go through that hole there and come out the exhaust. We control this back and forth manually with the knob here, so we can also get a little bit of, we can open it slowly, move it very slowly so that we just open a little crack until we're fully open. So it would be a way to manually cushion start a cylinder. Let's see if I can get this back together properly now. So that's my control that moves it back and forth, and it all locks in place with a snap ring. Yeah. And there it is. This valve and many of the pieces aren't here, but again, this has got a pressure port, 2 working ports, and an exhaust port. When we look at the top here, the exhaust port goes straight through. This pressure port comes to this hole here. This pressure port comes to this hole here, and my supply comes to this hole here. In this case, the rotary disc is made of nylon, and it sits on here, and it can just rotate back and forth. There would be a pin here for it to, an axle for it to rotate on, but I haven't seen that for years. In the disc here, I've got 2 grooves, each covering close to 90 degrees of the surface, so that when I put it on here, two ports can be connected through this groove, and the other 2 ports through this groove. I can turn it 90 degrees, and then instead of these 2 and these 2 being connected, it will be these 2 and these 2. And we get our 4-way action that way, same way. These 3 valves are all direct port connections, so the threaded port is part of the valve. And if I need to do repairs on the valve or replace the valve, I have to disconnect all my tubing and piping and replace the valve and put it back together again. This valve mounts on a sub-base. This is part of a base. We can have a bank of them, and they're set up with a pressure coming in and 2 exhaust ports and 2 working ports off on the side. On the valve itself, we have the connections to go in for, so we can get two exhaust ports, supply port, and 2 working ports, which will line up with these holes and with all our connections. This, if I needed to service or replace this valve, I just have to take out these 2 screws, take it off, and drop another one on, and I can service this and keep the machine going. So now we have taken some screws and parts out, and let's take off my solenoid and my actuator and pull the spool out of the valve. This is, get the spring out of there so we can see it. This is called a packed spool valve because the O-rings, which is our seal, or it used to be called packing, are on the spool, slide back and forth with the spool. These provide sealing between the ports. Let's see if we line this up. In this position, every port is isolated from each other. I can move back and forth, and we see we open, because in this position, this one and this one can connect, and this one and this one connect, and this one's blocked. If I move this way, then this one is blocked. This one will connect to this one. This one will connect to this one. So that's my 2 positions, 4-way operation. Okay, slide the spool back in. We can see how the spring moves back and forth. In here, this is my solenoid up here. Will open and close just to allow pressure to come in and act on the end of this to push it to one position. Releasing the pressure will cause it to come back to the other position. And that should slide in there, and then This is another 5-2 valve. It's manually operated. Has two positions. I've got most of the parts out right now. On the end here, port 1, port 2, port 3, port 4, port 5. Supply, 2 exhausts, 2 working ports. Although with any spool valve, we can we don't have to be connected up that way. We could put pressure into port 3, we could put pressure into port 5, we could put pressure into any port we wanted. It depends what you need in the circuitry, but most common, and that's the symbol is showing, port 1 is the supply. Though if you look at the symbol, the arrows there's arrowheads on each end of the flow path, so the air could flow either way there, depending how you connect it up. So I've pulled the spool out. You see there's no O-rings on this spool. The sealing is between, on these rings here, it fits nicely in there, and I have a whole lot of these rings. I'm only going to pull a couple of them out because it takes forever. Yeah, they don't even want to come out now. Here we go. So I have O-rings between stages. I have the sealing inside that the spool slides across. We call this packed bore because the seal is in the bore and the spool moves freely back and forth. There are a series of these cages that will line up with each of the ports so that there's place for air to go through, and these will sit on here, and the spool slides back and forth relatively easily through it. Not long. This we put together. There's no twisting or rotary motion for these. We just have to get them all lined up the right way in there, and that should go in like that. Put this piece on the end and cover on that side. That goes in there, and it's almost all back together except for putting the screws in. This is a partly disassembled spool and sleeve valve. Here's the spool. You'll see there's no O-rings on the spool. This is the sleeve that the spool slides in. You see there's no O-rings inside there. These O-rings are just to keep it sealed tight against the body. This slides back and forth in there to give us our various different positions. This slides very easily because these are made as a match set, honed together. They're very tight clearance in there. This valve will always leak a little bit, but that leaking is an advantage because then the air will leak between the lens of the spool and the inside of the sleeve and become like a air bearing, like an air hockey table that can slide back and forth very easily with very little friction. And this valve shifts very easily and very reliably as long as the air is clean and dry.